experiment number 2 to find out if the same mathematical relationship exists between any codon and its complementary codon. Previously, we discovered in experiment number 1 that any codon within human DNA has a particular frequency. In other words, it occurs a certain number of times in the entire genome or in any one length of DNA. What we found was that the frequency of any codon is the same as the frequency of its complementary codon. Hence, there is a mathematical relationship between the frequency of any codon and its complementary codon. What we're doing today is looking at the world's smallest genome, Nanoarchaeum Equitans, to see if the same relationship, the same mathematical equality exists in this organism between any codon and its complementary codon. So we click on here to see what the results are. Okay, it's finished scanning the entire genome of this organism, and we have the frequency of each codon here and here. Once again, I've divided up all 64 codons into 2 columns of 32. In the first column we have 32 codons, and in the second column we have the complementary codons corresponding to the first column. In this column here we have the ratio of the frequency of the first column to the second column, and as you can see, all of the numbers here are very close to 1. The results we take here and we copy them into a spreadsheet. We'll create a new file for this, so we go new, and we paste in the results and we insert a line graph. We can expand this to make so that you can see it more clearly. There. Drag that down. And as you can see, there's a very close correlation between the frequency of any codon, shown in purple, and the frequency of its complementary codon, shown in blue. The correlation is very high indeed and approaches 1. So the same mathematical relationship has been discovered between the frequency of any codon and the frequency of its complementary codon in the world's simplest organism.